Okay, thank you very much. It's my pleasure. In fact, this is my last pleasure as program director, at least for a while. So it's been an interesting 3 or 4 years in this role as we've gone through COVID and all the things that we've been doing. This is the last of the hybrid meetings that we're going to hold. That is where we're going to broadcast live to an online audience, as well as recording on Zoom and having our membership here in person. Starting in the fall, the board has agreed that we're going to drop the hybrid format and simply have meetings in person right here, as we've done in the past. We will record meetings to Zoom so that they can be put up on our new YouTube channel. I finished uploading the videos from the last year's talks, but we aren't going to make that channel live until later in the summer. So you'll hear about that. And in the future, people that can't make the meetings can certainly look up the talks later. So, okay, with that, let me get my readers on, Chris, because I can't read these things either. It's a pleasure to introduce one of our own as our speaker tonight, and that's Andrew Alden. And Andrew is somebody who's been very, very important to us in terms of handling social media and web and other types of things that many of us who are probably some of us younger than you don't really understand completely. So good for you to be on top of it. Andrew actually earned his BA from the University of New Hampshire in 1974. So we were almost neighbors. I was in Massachusetts in 1973, so not too far apart. He began serving as a scientific copy editor, occasional field hand at the USGS in Menlo Park. He left the survey in 1984 to work as a freelance editor. And he, other than a 10-year stint at technical firms, pursued this career until he retired in 2023. So a very recent retiree. Congratulations on that. He's been writing and speaking on geological topics for global and local audiences since 1997. He began his ongoing Oakland geology blog in 2007. The book, Deep Oakland, How Geology Shaped the City, which is going to be talked about here tonight, is just been published. So we're delighted to have you here to share with us your insights about the geology of Oakland. So Andrew, good luck.
Thank you, Jim. And thank you all. I made a count. I looked around the audience tonight, and about 10, maybe a dozen people here are people who I thank in my acknowledgements, because one, you either helped review a chapter or you simply helped me understand California geology better over the years. I have a little script for the beginning, but I'm just going to talk off the cuff for most of this talk. And if you'll stick, do we have, there we are. Let me share the screen. Can you do that for me? No, I don't have it up. Okay. Beautiful. There we go. Excellent. Yeah. All right, here we go. Oakland geology, answers and questions. Well, Oakland, the city, has always had an underdog energy. Yes. And even with respect to its geology, Oakland is kind of a forgotten stepchild. It's not the site of profound research topics or key localities. But as I've explored the city, I've discovered that Oakland is a great place to learn about a wide range of geological topics. And I've met many people who have told me that growing up, among Oakland's rocks and landscape led them to pursue geological careers. I think the most prominent among those is John Wakabayashi. He's an Oakland guy. So let me say a bit about myself. I've, as Jim said at the beginning, I've mainly been a copy editor. That's what this background is about. That's been my business, chasing little beetles on screens and marking them up. But I've also spent time out in the field. When I was at the USGS, I was lucky enough to go up on cruises to Alaska 4 different times, and I even got on shore a couple times. And then afterward, I began writing about geology, and I made it a point to travel all around California looking at stuff that interested me and excited me, and share that excitement with people online on about.com and KQED and so on. So I've been doing this for a long time. But I want to recognize tonight's talk. It's sort of a throwback occasion. And I say that because the early scientific societies from the 1600s until the mid 1800s welcomed serious amateurs. Now, I have a bachelor's degree. I was never a master's. I never worked as a geologist. I'm not a licensed geologist. I'm a member of the geological community. I know my way around a paper. I read papers for pleasure. I'm one of those guys. But I've always had a little hesitancy about saying I'm a geologist, because I can't advise you on your foundation or any of that stuff, or where to drill for oil. So in that respect, I call myself an amateur, and I say, so I think about the early scientific societies, and amateurs presented papers to those societies and had them published. And so tonight I'm grateful to the NCGS for granting me the same privilege. Now, writing a geology book, especially for an author who is a geologist, is more about leaving things out than putting things in. One reviewer said, I didn't learn much about geology. I was okay with that. I was okay with that because that was a reader who actually knew some geology. What I really want is for people who've never thought about it to be lit on fire about geology. I wanted my readers to learn only as much as they had to understand what was in my book. So I tried to keep my lessons right, but light. And also I must point out that my editor at Heyday Books was very strict about my word count. But they told me, if your last draft, lose 2,000 words. And I'm going, oh, okay, yeah. So, but on the whole, it was a good thing having to write a short book. And when it came to writing the book, I didn't have to learn any general geology. I just had to dig into the literature and contemplate the landscape. That included local trips with NCGS, starting with this one in 2005 up at Sibley Volcanic. I also had to learn enough local history to get all the essentials. And by that, I mean, when you know enough, when you know what you need to leave out. And so doing the research for that book involved not just investigating the land, but investigating the written records. And all of that was a really pleasant part of writing this book. Deep Oakland is a joint inquiry into the city's human history and its geological history. So tonight, I'm not going to go into human history a lot. I'm going to nerd out with my fellow geologists as we explore deep geological Oakland. This Oakland. The abstract in our newsletter described what I learned about Oakland in 2 elaborate sentences. And this is the first one. 12 years ago, I presented this sentence to a lay audience. It was the Oakland Heritage Alliance. And I impressed them greatly. So I reproduce it here, not to impress, but just to inform you. Oakland's bedrock represents the accretionary wedge ophiolitic complex and foreland basin of a westward stepping Mesozoic subduction regime and succeeding tertiary foreland sediments on a foundered slab wedge. That was, don't ask me what I meant by that. Dissected by ongoing transcurrent wrench faulting with eastward dextral transpression. Yeah. So in the book, I turned as much of that as I could into simple language, and I skipped some terms. I didn't talk about wrench faulting, which I've not really understood. I didn't use the word dextral. I didn't use the word Mesozoic. I didn't use the word tertiary, you know. But I did want to, I started the book, and I'm going to start tonight with our last bit, the dissection, the Hayward Fault. That's the most important thing in Oakland geology. And it's dextral, as you see with the arrows, the right side of the fault is going to, the opposite side is going to the right. And I expressed that this way on page 4. I defined the word transpression very carefully. And I did that a lot. Geologists call da 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 da. And I said the fault is why there are hills here at all. I also explained fault creep and earthquakes, and I pointed out what brought up the subject by pointing to the cracks, the en echelon cracks that you'll see in various parts of the streets and in Lake Temescal Regional Park, and introduce creep that way. And I wanted to know I wanted people to know that the Hayward Fault is famous. Oakland is famous, even though everybody goes to Hayward to see it. You should go to Oakland to see the fault. And then let me get to that. The other sentence that was in my abstract, the one that was in the newsletter, was about the landscape. You know, the first sentence was about the bedrock. This is about the landscape. It represents the combined effects of quaternary orbital cyclicity and tectonic action on the diffuse North America Pacific plate boundary. And the tectonic, I wanted to make sure right off on page 2 that people really understood what tectonic means. So I made sure to do that. That in case, you know, none of you were clear on that. And but this should be obvious to you. This is what tectonic motion does. These are Oakland streams. And the fault runs across the upper part. And you can see that on the west side of the fault, the streams are all beautifully organized in beautiful patterns. And then the fault just rips them all apart. And on the east side of the fault, they're completely different. The ground is organized differently over there. And so when you play the fault backwards in your mind, you can see the way the streams keep getting disrupted and beheaded and distorted. But you also see that this blue blob on the left, which is the block of Franciscan rocks that underlies the city of Piedmont. If you take it back 1 million years, it's about 10 kilometers. It puts you opposite the San Leandro Gabbro. And so this is my contribution to science in chapter 6. It takes me 6 chapters to get up to this. But my theory is that the uplift of that block happened when it ran into the San Leandro Gabbro. 2 immovable objects met by an irresistible force. And when that happens, the only place that can go is up. So that was the scenario I envisioned. That's what I call the hip check hypothesis. And this is how I described it after this long preamble. Like a shovel passed under a buried paving stone, this passing collision would lift the Piedmont block out of the ground, lifting the alluvium on top of it as well. And so there's another corollary to that hypothesis that is the curiosity of Saucil Creek explains. Saucil Creek, it cuts right through this block. And it's kind of interesting. The upper streams in Saucil Creek actually have independent names. Saucil Creek actually gets its name at the Hayward Fault. And that's very convenient because those 3 upper streams are only temporary headwaters of Saucil Creek. Saucil Creek has been cutting through that Piedmont block, in my estimation, for 1 million years. And here's how it happened. Cutting what we call Diamond Canyon. And Diamond Canyon is a classic water gap. It's almost a classic water gap. It's hundreds of feet high, the walls of the canyon. It's solid rock. There are no faults or no structural features there. It's just solid rock. And the stream, see if I can, yeah, it does play. The animation plays. This is, after a lot of rain in the end of December, and it's not much of a stream. This is not a stream that can cut a 400-foot deep canyon through solid rock, not with the watershed it has today. So I made this little animation to show you what it would look like. Oh, didn't happen. But anyway, you can see how it would kind of rise. And as it was rising, this powerful stream, San Leandro Creek, which runs through San Leandro Canyon today down in San Leandro. That's what cut the canyon. That's the corollary of the hip check theory and supporting evidence for my hypothesis. So Diamond Canyon is a water gap. It's an odd water gap, like a lot of Oakland. It's a beheaded stream valley. And then another corollary of the Piedmont block is that its watershed has been on the one side of the Hayward Fault. It has escaped all the disruption that we saw of every other creek in Oakland. It's been sitting there for 1 million years, according to my hypothesis. And that's why it has this beautifully developed drainage pattern, like the sketch of a tumbleweed. And so let me bring in the other phrase in that sentence, quaternary orbital cyclicity. This is one of many compilations of global sea level. It was published in 2016, and it shows the last 800,000 years when this was after the mid-Pleistocene transition, when all the ice age cycles switched to 100,000 years. The transition was actually at about 1 million years ago. So if you're thinking of Oakland's landscape over 1 million years, we've had 10, 11, maybe a dozen glacial cycles in that time. And each one, as you'll see by the sea level scale on the left, amounted to about 130, 120, 100 odd meters difference in sea level. Right now we're up at 0, but at the peak of the ice ages, it was as far below today's sea level as Oakland's buildings are tall, for 400 feet, 130 meters. And so when that happens, you know, you're changing base level. You're dropping it by 130 meters, and you're leaving it there for tens of thousands of years. And so all these streams, all the big streams, are going to cut canyons, right? And so, as I explain, over repeated ice age cycles of digging and filling, because they come back, the ocean comes back and it fills in the canyon each time. The catchment of the Piedmont Block has helped maintain the unusually deep trough cut into the coastline and dug straight to the bay that now holds Lake Merritt, which is unique in the East Bay. It's the only thing like it in the East Bay. So it needs a special story. So that's it. That's why we have Lake Merritt, Oakland's crown jewel, enhanced incision due to Quaternary Ice Age cyclicity. Oakland has some other interesting Quaternary landforms in the landscape. And one of them up on the top, the Pleistocene alluvium. This is that apron of, in my interpretation, this is that apron of ancient sediment that formerly buried the Piedmont Block. It rose along with the bedrock, and it's gradually being eroded, which is why I likened it to the outline of, the outline on the map is like a tattered Japanese paper folding fan, which is why I call it the fan in the book and on my blog. It's that's the name I've stuck it with, and that's the name it's stuck with. And of course, down on the lower right is another actual fan, an alluvial fan. It's a San Leandro fan that San Leandro Creek has been building for the last, on that current iteration of its lower stream. And that's all I'll have to say about alluvial fans and groundwater and so on. But this is what that stuff looks like. This is the stuff of the fan, the fan. It's indurated clay gravel. It's so hard that in fact this is a construction site. When the forklift, the bulldozer or forklift cuts into it, it actually cuts through the stones, because they're held so tightly, and presumably the stones are a little softer now after, you know, being there so long. And then the other quaternary feature is the pink field quaternary dune sand. And these come from the latest phase of the Ice Age, when there was no San Francisco Bay, it was just San Francisco Valley. And the winds came pouring in through the Golden Gate for the first time. The Golden Gate did not exist the last time we had low, not about 150,000 years ago. It was not there. The bay's drainage was different then, and I'm skipping that part. But dune sand blew all over San Francisco, which is why San Francisco is covered with dunes. And all the way across the bay, there's thick beds of it underneath the bay. And all the way over here. All of downtown Oakland is on it. This is the platform. It's beautifully flat, and it's beautiful building foundation. Stuff looks like this. The Aeolian clay sand doesn't have any pebbles whatsoever. And it's everywhere. It makes good foundation material. So I reassure people that downtown Oakland it's not like the rest of near shore Bay Area when it comes to earthquake safety and liquefaction potential. And then the other interesting feature is this little thing, a terrace, a marine terrace from the last high stand of the ice ages. This was the last time the San Francisco Bay existed about 125,000 years ago. Marine isotope stage 5E, also known as the Sangamon Interglacial. And it's this beautiful terrace the Lakeside Park sits on. And the other part is over in near East Oakland. And you can see how flat it is. It's like a billiard table. And it's made of this top layer of estuarine clay. This is I'm always on the lookout for things like this. This is in Lakeside Park when they were doing a bit of construction. And then down underneath, it turns into gravelly mud, this typical alluvium you'd expect from the Oakland Hills. So that's kind of interesting. Oakland has landforms from two different phases of the ice ages, and they're practically identical in elevation. They're just a couple of meters apart. And when you look at when Oakland's first days, Oakland was settled in 1850 when a group of squatters rode across the bay and claimed land claims here on this field on the left. The pinkish spot down by the harbor. That's where it was different from every place else in the East Bay. It was not marsh. It was not rocks. It was a place you could build a town, you know. And the same thing was true over on the right edge of the map. And in 1857, there were two towns here. One was the young town of Oakland on the left, and a little town called Brooklyn, which is actually older, on the right. That was used to be where they did all the shipping of timber from the redwood rush of the 1840s. But anyway, that's where they line up on those two different landforms, which were the natural places to build cities. And so there they are, you know, we have Brooklyn on the one and Oakland on the other. So we are done with the quaternary part, the landscape part, and now back to that ridiculous sentence at the beginning. We'll talk about the bedrock in Oakland. And fortunately, it all makes sense in terms of subduction zones. And I was really grateful that my illustrator added this diagram, because it really, the book doesn't have much in the way of illustrations. I've really relied on the writing. But when it comes to subduction zones, a diagram like this just is real essential. Keep track of it. I know it's all old hat to you folks. But that's what makes sense of this mess that is the Oakland bedrock geologic map. I'll start with the accretionary wedge, which is actually a term I did not use in the book, didn't need to. But it consists of 4 parts. The Franciscan, the accretionary wedge, the subduction zone consists of 3 parts. The accretionary wedge, the ophiolite, the foreland basin, 4 parts, and the volcanic arc. The accretionary wedge is represented by the Franciscan. And I didn't actually explain it until the very end of the book. I talked about the Franciscan because it's hard to talk about. You know, it's a long story, the Franciscan. I just described it in chapter 5, and then I kind of referred to it. I wanted people to become friends with the Franciscan the way we are, you know. So I took my time introducing it in the book. And the Piedmont block. This is a shot of, it's hard to photograph. This is a picture from the north end of Oakland up in the hills. And it consists of melange, which also took a lot of explaining, but you're familiar with it in Mountain View Cemetery. And I was pleased to devote all of chapter 4 to Mountain View Cemetery, not only because the landscape is interesting, but because it has some interesting people buried in it. Now, I talked about geologists, but for you tonight, I'm going to show this one. This is Mr. von Schmidt, who surveyed California's eastern border. If you look closely at detailed maps, you'll see this kind of dashed line. That's called the von Schmidt line. And it's called the von Schmidt line because he was surveyed at first, but they came along later and found that he was about a half a mile off. But here he is. He's here in Oakland. And we also have melange consists of blocks. This is my favorite one. This is a block of Franciscan chert, deep red chert from way out in the Pacific. And then the rest of the block, the Piedmont block, is sandstone. And that was the sandstone was why Piedmont was important, because it yielded rock quarries. It produced crushed stone with to build Oakland from. And it was so close to downtown that, you know, whoever had a quarry it eventually became very wealthy. And so they made Piedmont into the wealthiest city that it is today. The other cool thing about the Franciscan is it does have high grade blocks in it. Like this beautiful pod of blue schist on the Mills College campus. Now that the area is interpreted as Franciscan complex, but there is blue schist elsewhere, really in the Franciscan. And then there's the ophiolitic complex, and Oakland has 3 pieces of it. I explain what it is, because otherwise, who cares about an ophiolite? It's a chunk of seafloor crust marooned on land. And they're cool things. And California is really cool to have the Coast Range ophiolites scattered all up and down the Coast Range. And Oakland has some pieces of it. Has 3 pieces of it. Has a chunk of serpentine. I did not use the word serpentinite in this book. I just talked about serpentine rock. That's how I explained it. There's mantle rock with infiltrating superheated seawater hydrated its dark crystals into glossy sea green minerals. That's how you know it when you see it. Because I couldn't show a picture, all I could do was describe it. And then we have what geologists have always called, with quotes, the Leona rhyolite. It's not really a rhyolite, it's a metavolcanic clastic unit that we have learned is actually a subduction zone complex of ash flows and hydrothermal alteration and albertization, which incidentally impregnated it with pyrite. That's why every place you see it, it's orange. If you get a fresh specimen, it's light, but you expose it, it gets darker and darker. And in fact, it got so thick, the deposits of oxides on top of it, that the Ohlone Indians used to mine it for ochre. And it was it was their monopoly. They had a Bay Area wide monopoly on ochre. So even in the old days, the residents of Oakland were wealthy people. You know, they had stuff to trade and make the Ohlone equivalent of money with. They could trade it for obsidian and cinnabar and salt and abalone beads and things, you know, all sorts of valuables. And then, of course, later the Americans came along and they discovered the pyrite. And at the time, pyrite was a valuable commodity and it was mined for some 30 years. And that's why I have this picture on the lower right showing acid mine drainage from those days, 100 years ago. They mined pyrite because that was the basis of the sulfur industry. You would take pyrite and roast it. And the sulfur oxide gas, you would render it into sulfuric acid. And they don't do that anymore. They just pump sulfur from the ground down in the Gulf states today. Or they make it out of gypsum deposits. And then the third piece of the ophiolite is a big body of gabbro that I described down at San Leandro. And there's a little of it in Oakland, not a lot. It's not very impressive. There are a few bits of it. And rather than actually say what gabbro is, because, you know, how many of us can say it off, off the cuff. So I just called it a cousin of granite. That's close enough. Everybody knows what granite is. So by that time, and then the last thing is the third part is the foreland basin. And I had to explain that because, foreland, it took, it didn't, the term doesn't really explain itself very well. So I explained, this is how I describe the textbook subduction zone. And the foreland basin is between all the active parts. It's the passive part. But each of those parts has a characteristic set of rocks. And in Oakland's case, it's the Great Valley sequence. These are just little slices of it. The Great Valley sequence extends through Cretaceous, and informally, more of it goes into the Eocene. But Oakland's pieces of it are mainly from the late Cretaceous, mainly Campanian, a little Maastrichtian, and a little, what's the one before? The Coniacian, is that one before that? And they are divided into a half dozen different formations, but they're mainly just clastics. There's sandstone, like the Redwood Formation, Redwood Canyon Formation. And the other distinctive one is the Oakland conglomerate, which makes up the ridgetop for most of southern Oakland. If there's a bicycle trail along the median of Skyline Boulevard, which is in two divided road up there, and if you walk down that bicycle path, you'll see outcrops of it. It's great. And then finally, the last bit of rock in Oakland is the tertiary part. After the subduction zone was broken up by the Hayward Fault, that's the Hayward Fault again. And that is this huge belt of Neogean rocks, which is what the Mount Diablo volume is all about. Fortunately, I didn't have to explain any of that. I just said, here they are. They've got mudstone. This is going up in age. The Sobrante, what's traditionally assigned to the Sobrante Formation, it's mudstone. We have this wonderful chert, the freshwater chert of the Claremont Shale. It's the same stuff as the Monterey Shale, and then you can see a bit of it in the background up along Skyline Boulevard. It's beautiful. I likened it to a forest, a wind-blown forest of golden bamboo, because that's what it looks like, And another conglomerate, we actually have three different conglomerates in Oakland. This is from the Orinda Formation. And then finally, we're getting to the volcanics up in Sibley. There's this wonderful stuff. I put that back in the path. If you're going up there, you may be able to find that. And also some freshwater limestone from those days. That's actually not in Oakland. That's over on the Orinda side, but And then finally, basalt of the Bald Peak Formation, which takes us up to about 9 million years ago. And so Oakland just has an enormous variety of lithology and it's got all the pieces of the subduction zone. It's got a major active fault. It's got quaternary stuff, ice age stuff. Oakland has a whole textbook of geology in it. And I didn't know this when I moved there. It was a discovery. And I was so excited about it that this book took shape in my mind about 10 years ago. Now, I say questions. This is not question period yet, although we should do it very soon. But questions for you guys. One, is the hip check hypothesis legit? Does that, what do you say to that? Does that make sense? I don't see a lot of nodding. Okay, it's okay to be skeptical. And what about this explanation for Lake Merritt? Does that make sense? I think it does. I'm real strong on that one. And are we ever going to make sense of what's underneath the East Bay? When I was looking into this, so much of it is informal. It's based on boreholes. They're poorly correlated. The history of the Bay Area is so complicated. I just not sure how well we really know it. And there's no offense meant to people like Doris Sloan, who's worked on this for her whole career. How well do we really know it? And how well will we ever know it? And how much more can we learn from Oakland's rocks, either from the Great Valley sequence or the Coast Range ophiolite? Are these just interesting little bits, or are they significant? Now, that's something I have no way of answering. People who are real experts and future grad students, people like that, it's up to them to work on that question. But in the meantime, we can speculate. And I keep this quote in my head all the time, because we can think about things without evidence at all, or just a little bit of evidence. A lot of when I was writing the book, I just relied on what people had already concluded. I didn't do any original mapping of my own, and that's the basis of my conjectures. But I'm still wondering. And now maybe you have some questions. Please. If you have a question, please come to the microphone. Yeah, come on up.
I don't know whether the camera will pick up my black eye, but it was due to a fall, not my wife. My question, Andrew, is you made a very interesting thing. I grew up where the glacial ages, Pleistocene, was covered with ice in northeastern US and Canada. My question to you, I'm not very knowledgeable about what happened during the Pleistocene in the San Francisco Bay Area and Oakland area, but my understanding is that there were no glaciers as far south. And you made the point about the erosion in the stream erosion being rather extreme during one or more of the ice age cycles, either the low sea level or the high sea level. Was the pluvial period when you had more rain, was that at the time of high sea level or at low sea level?
I'm not familiar with the pluvial period.
High rainfall.
Yeah, but Well, actually, I went to school in the East too. I spent a lot of time in the East, and yeah, you learn about the Ice Age. You go to sand quarries and you look at it, and it's just, it's outwash. It's gravel. You see you see moraines and eskers, and you see loess. And none of that, when I came to Oakland, it's totally different. So it's not the same at all. And it was a kind of a thrill to expand my ideas of what Ice Age deposits looked like. So the thing we do have in common, the East Coast and the West Coast, is this whole thing about incised canyons. So that was familiar, and it was neat to actually think of San Francisco Bay as a drowned valley, just something you think about on the East Coast all the time. So if you're talking about when you say the pluvial period, if you mean the high stand, the warm periods, yeah, that's when the high terrace was laid down. Presumably, yeah, it was wetter then, the hills were eroding faster. There was more sediment and clay, yeah. Yeah.
Bob, go ahead and ask your question. We can hear you. Unmute your microphone, please.
Actually, I can read it too. Yeah, Bob Carloni is asking, is there anything in Oakland similar to the volcanics in the Cragmont area of North Berkeley, for example, Indian Rock? I wish there were. The volcanics in Berkeley and El Cerrito are younger than the Moraga Formation. They're a couple million years younger. They were erupted somewhere else, and they were brought north. They're on the other side of the fault, so they're not directly related. So yeah, I wish there were. I was looking around. I keep my eye open. You never know. But so far as I can tell, no. The answer is no.
All right, so on a couple of your maps, you showed Alameda. And I always understood Alameda was underlain by sand and was called the Merritt sand. So could you just describe how that fits into what either the dune sand or the upper terrace, or maybe it was or is something unique unto itself?
Yeah, Alameda is a twin of Oakland. They're the same stuff. There are actually three bodies of dune sand on the East Bay, and the third one is a little bitty one. It's Bay Farm Island, which is now a neighborhood of Alameda north of the airport. But yeah, Alameda has the simplest geology possible. It's just a big old sand dune. The highest point in town was an Ohlone shell mound. And so, yeah, that's all I have to say about Alameda. Alameda could be a pamphlet. So anyway, thank you all for coming. I love the June meetings because now we can all go out in the field. And we'll see you all in September. Thanks again.
Andrew, we have a traditional gift, which is a NCGS mug. So again, thank you very much for
All right.
for your morning coffee. So very good.
It's beautiful. I'm touched, really.
Very good. Thank you. Good job. Okay. We'll see you all